Saudi Arabia as a draftsman before. So we have five. I think we have five different departments. So the architecture departments, electrical, mechanical, engineering, and we have interior design. So these five departments are having a collaboration for one project. So here it goes. So the first one, the first one who will do the first things, the architecture department. So basically, they will produce the 30% of the drawing, the floor plans, elevation sections, and floor plans, elevation sections, and also reflective ceilings. So all of these things, when these are produced, all the constructions department can easily do their work hand in hand until the project was done. And the good thing with BIM also, they can easily store this one on cloud. Cloud is similar to Google Drive, storage, yes. So whenever you have an internet, if for example the boss is nowhere around and he wants to see what's the project, he can easily see through cloud. So that's one of the benefits of architect, of being for the architect. Next slide, please. So that's the one. Next. So this is one of my one of the projects that I had worked on to when I worked in Saudi Arabia. They're using BIM for this one. So this is the King Saud University endowment. So this is composed of 11 buildings. It composes of residentials, commercials, shopping malls, and hospitals and other facilities. And the other one is this one, Saran Business Center. So this is a shopping mall also, but it's a mixed use. The upper part was used for the offices. And lastly, the King Abdullah Medical City in Makkah. So if you're going to work in Middle East, the Makkah city is very sacred for the Muslim. So there are a lot of developments going on here. There are a lot of projects that been putting up on this because this is very sacred for the Muslim people. So one of these projects that we have is this King Abdullah Medical City. So that's it. I hope you learned something from it.
Thank you, Architect Malaba Jr. for the heartwarming and informative talk about building information modeling. For our next speaker, she is also a graduate of Bachelor of Science in Architecture from Mahua University. She took her master's degree specializing in urban design in University of Pennsylvania. Currently, she is pursuing her MBA while being a senior partner of the renowned firm ND and Partners. Let's give it up for architect Jonathan Gregorio.
Thank you very much for that warm introduction, sir. Hi everyone, how is everyone? Okay. Before I start, I would just like to ask if any one of you has seen the movie Skyscraper with Dwayne "The Rock" Johnson. Anyone? No? Okay. Why I'm asking is because the building that was featured in it is an example of what I will be discussing today, which is the vertical cities. Now let's start with the current issue. We can't deny that we have a problem with overpopulation. Our global population today is about 7.6 billion, and experts believe that it will increase to 9.2 billion in 2050 and 11.2 billion in 2100. with more people occupying our lands, we need more structures to accommodate them. And by building this, and with building these structures, we cause environmental destruction. We destroy our forests, our natural habitats, and with that, we limit our natural resources, endanger wildlife, and destroy our ecosystem. If we don't find for a solution now, there may come a time that our population is more than the environment can handle, and it can't support us anymore. So more and more people are looking for the vertical city concept as a solution to the growing problem. What is a vertical city? Vertical city is an arrangement of interconnected megatowers that could support hundreds of thousands of people. May I ask who here lives in a condominium? Anyone? Apartments? Yeah. And what about your everyday necessities, ma'am? Do you go down to buy them, or do you go to the market? You buy downstairs. There's a lot of retail establishments around right now in condominiums. The same applies to vertical cities. Actually, a condominium is just a prototype of a vertical city. A vertical city contains houses, retail stores, schools, offices, services, and outdoor recreation in just one building or in a series of an interconnected building. So why would we need this vertical city if we could just expand outwards as we are doing now? Well, because building vertical cities lessens our impact in the environment. Containing large amounts of people in such a small footprint, we reduce our land use, and with the conserved land, we can now produce food and leave it as a natural area. Next is mobility. If your school or your office and your home is just in one place, it is easier now to move in one place to another. And these buildings may also foster social interconnectedness by making it easier for people to socialize in common spaces. It can also be outdoor recreation spaces, sports areas can also be integrated in the outdoor parameters. Now with food, have you guys heard of vertical farming? Yes, vertical farming is not a concept now. It is, I believe, there are some who exist, and the idea is currently under development. But if with the scarcity of land, it may provide a solution to the growing problem also. So if vertical towers should come to fruition, it is vital that we separate concept to reality. What do I mean by that? It's important that we separate what we actually have right now to fiction. The most common problem and the most big problem that we have right now, that's why we can't build vertical city, is that we don't have enough money to fund it. The maintenance of the buildings is costly and time consuming. Another problem is that the presence of these skylines could disrupt the feel and culture of historic communities. Another concern is about the emotional well-being of the inhabitants. It is proven that staying indoors could actually cause negative emotions and harm to the inhabitants. So this could be solved by integrating outdoor spaces in the buildings and recreational areas. And probably the most important aspect that we should focus into when building vertical cities is the safety. The building will have to be resilient, and it should withstand natural calamities like earthquakes, tsunamis, and the likes. And also, extinguishing fire in a high altitude is difficult for the firemen in the lower ground. So as the height of the building rises, the margin of safety is lessened, and it is much more important that the details are scrutinized one by one. So So is it actually feasible to build vertical cities now? If we will see vertical cities in the next decade or so, it is uncertain. But we do have mega towers now, like Burj Khalifa, Taipei 101. And architects are actually theoretically designing what if a vertical city would come to fruition. For example, this Italian firm, Luca Sursi Architects, has designed a 180 stories tall building with green spaces. It lets natural light and air in, and there is a lot of common spaces for people to socialize. It is located on water and can be accessible via land, air, or water. It is a concept for now, but who knows, with the scarcity of land and our growing population, we might come to see it soon. Building and maintaining a vertical city is costly, and it requires extensive amount of planning and research for us. But it holds the key to solving humanity's biggest challenges. But unless someone else thinks of a way of a solution to our overpopulation problems, like civilization on Mars or something, the vertical cities is the most probable solution to sustainability and ultimately the survival of the next generations. Thank you.
Thank you, Architect Jonathan Gregorio, for that insightful talk about vertical city. Our next speaker is a graduate of BS Architecture from Abuo University. He established his own firm named EP and Associates. He established CEP Architecture and Design Incorporated, this time tackling bigger projects alongside a pool of younger architects. His design philosophy is centered on his own brand of classicism, which is defined as a life-centric architecture. Let us all welcome architect Lee Prieto.
For the introduction. Also, good afternoon, guests, also architects, especially architect men of Norfolk County. So I'm going to explain to you today is intelligent building systems. So just imagine with enough ego and abundance of technology, it is the new beginning it is the new economical impact of every building today. It has the impact of economical and ecological aspects, also decides as intelligent architecture. So just imagine you're a worker. Would you work in a office space that has, let's say, the building has no productivity, no security systems, it has a bad, let's say it has a bad side of productivity, like no aesthetics at all. So it has a capability. So the intelligent building systems has the capability to make your life better, but the buildings should also run smooth because it is a technology working for you when you need it, and it does works for you when you don't. So smart grid buildings, especially, it works for you. Okay, the next is intelligent building knowledge-based society through the establishment of the implementation and realization of a comfortable life. So in the intelligent building systems, their main aim is the realization of a comfortable life. So through different types of aspects of in a room, for example, so you can see the CCTVs, the HVAC systems, the temperature control, the aesthetics of a room. It is the main aim of the realization of comfortable life of the intelligent building systems. So next is, what is intelligent building systems? It is the 21st century knowledge-based society to cope up with the environment of this space and culture, and also it also has the all types of aspects that which monitors and has the aspect of like all the rooms to know, and also to have a more productive space in every rooms and in this type of buildings. So also to build these intelligent buildings, construction, electronics, information technology, machinery, and energy environment should be a must. Next. So intelligent building aims to effectively incorporate and activate sensing, proactive control techniques to building design for creating a better human-oriented living space, possessing safety, health, convenience, comfort, and energy efficiency. So just imagine working in an office that it has it all. Like it has automatic systems, like it has automatic temperature control, automatic shading, also all the aspects like the system control and also the security in this building. So here are the aspects of these buildings. First of all is the HVAC, which is the heating, ventilation, and air conditioning. Is used to control the temperature of all the rooms in the building. And next is the lighting controls and solar panel for the sustainable aspect of the building. Next is the environmental controls, metering, and also for the access controls, especially to escalators and elevators, for the especially the security and the fire detection and alarm. So there are three main aims of the intelligent building systems. The first is the security, and the security is the sustainability and the productivity of all its users. So just imagine working in this office. Would you work in that office where there's no like that temperature is down, like all the lightings are off, that you have no monitoring systems in every room? And next, and would you work in this place like it has it all. Like it has the main aspect of the intelligent building system. It has the system controls, the securities, and also like everything, the shading, the ventilation, also the temperature control to have a more productive office space. Next, okay, so what do we mean by intelligence? So by intelligent is our view that intelligence is considered to have innate and general cognitive ability to produce the linkage of that building, the linkage to all of its users. Like for example, for a building that is more productive, it should connect us all users to be more productive. More productivity means has more efficiency, and efficiency contains cost. So what do we mean by intelligence? So ironically speaking, intelligent buildings are not intelligent, but they can make the occupants more intelligent. Like for example, in a building that consists of like it has a door, and also you could work even more productive you can even more work productive in every rooms of the building because it has it all. That is the main aim of the intelligent buildings. It's not just the building, but all of our users that intended there. So here are the four types and aspects of these intelligent buildings. So here are the main frames. So building structure, there's risers, spaces, and raised floor and drop ceilings for, especially mostly used in office buildings. Let's say it's a brand. Let's say for example, Armstrong is a brand name. Is Armstrong acoustic ceiling, especially for office spaces to minimize the noise throughout its offices. And next, the building management, energy and efficiency report. So in a system, the intelligent building system is capable to produce any types of reports like leakage of plumbing, and also to different types of the problems in, let's say, in the securities, or a problem in the air conditioning systems. And next, the building systems, heating, ventilation, air conditioning, lighting, and wiring. So in electrical problems, we should also know by using these intelligent building systems. So last is the building services, office automation, voice data, video communication, fax and photocopying. So it has it all. It has the security, also for being productive. Next is, so it's not just all of the office buildings should be used. And also five-star hotels mostly use it also. You can also use it in malls, especially in residential areas. So one of the aspects is the automated curtain wall glazing system. It is the motorized window shading and blind system for the users here in this place for being more productive. And next is the sensor controlled lighting strategy. The visitor kiosk access system, especially more used in the reception areas. And let's say it's all the system management of all the buildings. Okay, next is the building management system software. So as you accumulate all of these aspects of a building, it should be used and it should be compiled in a one system. So building automation system, it is the system that it connects with all. Like you all knows what the problem is, you all knows where it has a problem or some different types of where you need it. Next is also the categories, the infrastructure category, and the functions of different types of areas. So here's the last is green space, comfort, breathing efficiency, culture, high-tech image, safety, structure, management, practice and security, life cycle costing, and health and sanitation. So these are all aspects of which is the main aim of the intelligent building systems to create and produce a more viable and more productive spaces also throughout all our users. So okay, so thank you for listening, and I also hope that you use this innovation to all of your future as designers and also as architects. We design all of the aspects that we should use for our future buildings, and I thank you.
Thank you, Architect Prieto. So now, before we move on to our next speaker, let us have a quick intermission number to be performed by Mr. Jos Cano. Let us all give him a hand.
Pwede kayo sumayaw. Can count the years on the hand that we've been together, and with the other one to hold you, make you feel better. It's not a walk in the park to love each other, moving our fingers into love. Can't deny you're worth it. 'Cause after all this time, I'm still into you. See guys, I should be over all the butterflies, but I'm into you. And baby, even on the worst night, I'm into you. Let her wonder how we got this far, 'cause I don't really need to wonder at all. Yeah, after all this time, I'm still into you. Recount the night that first we met your mother, and to the drive back to my house. I told you that I love you. You felt the weight of the world fall off your shoulder, and to your favorite song you sang along to the start of forever. And after all this time, I'm still into you. I should be over all the butterflies, but I'm into you. And baby, even on the worst night, I'm into you. how we got this far, 'cause I've been living it to wonder at all. Yeah, after all this time, I'm still into you. Something just makes sense, and one of those is you and I. Something just makes sense, and even after all this time, I'm into you. Baby, not a day goes by that I'm not into you. I should be over all the butterflies, but I'm into you. And baby, even on the worst nights, I'm into you. Let them wonder how we got this far, 'cause I don't really need to wonder at all. Yeah, after all this time, I'm still into you. I'm still into you. I'm still into you. Thank you.
Thank you, Mr. Joscano, for that angelic serenade that you have given us. If you guys enjoyed his performance, you can follow him in his social media. To continue for our program, here is our fourth speaker. She is a graduate of Mapua University with a degree of Bachelor of Science in Architecture, specializing in project construction management. She is now the senior manager of the Jacobs Architects Los Angeles. Let us all welcome architect Jariel Perlas.
Good afternoon, everybody. Thank you for that wonderful performance. What I'm talking about right now is underwater architecture. So basically, underwater architecture is architecture that is underwater. Spending time underwater soon will be something exclusive for scuba divers. While the idea of living underwater is something far from new, technologies and architecture training have greatly improved to meet the formidable challenges in submarine construction. There are already several underwater structures that are up and running. And let's take a look at some of the examples, also some of the ideas that are becoming a reality in the world of underwater architecture. The first one is the Discuss Hotel. It is in Dubai. The Discuss Hotel is going to be the world's largest luxury underwater hotel. It has a $50 million budget and it is designed by a Polish firm, Deep Ocean Technology. It has 21 guest rooms and sit about 10 meters underwater. The next one, it is the Ita Under the Sea restaurant. It's already built. This one is designed in New Zealand by a firm that specializes in large aquarium works. It is 5 meters below water in Hilton Maldives Resorts and Spa. It is made of acrylic and it has a 270 degrees panoramic view of the seabed, ocean, and it only has 40 seating capacity. The next one is the Cancun Underwater Museum. This one is located at off the coast of Isla de Mujeres in Mexico. This is the world's largest underwater museum. It has a series of display of pH-neutral concrete which can only be seen by divers and tourists that are in a glass bottom boats. The next one is the Poseidon Under the Sea Resort. This one is another submerged hotel. It has a large dining areas and elevator to transport the tourists from sea level from 28 feet below the surface. This hotel is classed as a vessel because it can be moved. They are using the technology, electromechanical propulsion technology. And this one is the Planet Ocean Underwater Hotel. This one is just a vision for now. It has 12 guest rooms, as you can see. And it is 28 feet below sea level. It has, and this is the last one, the Under the Sea Restaurant. This one is in Burawanghay Island Resort, which is 5.8 meters below sea surface. It is made of steel structure with transparent acrylic dome. And this one is the largest underwater restaurant. It has 30 seating capacity. That's it for it. Thank you very much.
Thank you, Architect Gerald Perles, for that expounding talk about underwater architecture. For our next speaker, he is a graduate of Mapua University with a degree of Bachelor of Science in Architecture, specializing in urban design. He is now the CEO of LFP Architects and is a strong advocate of social architecture. Let us all give architect Chris Bisian a round of applause.
So I personally want to thank you all for coming in here. So happy to But before I start, so last night as I was preparing the slides for this talk, I was feeling very excited because this topic is something very interesting to me, and I hope that it's interesting to you as well because architecture is very demanding, very tricky, very complex. So we need thinkers, innovators, and to do that, we have to be interested in many things, and we have to be hungry for knowledge, and we have to read books so that about things that interest us because readers are leaders. So without further ado, I'll start with my topic. So immersive, by definition, means generating a three-dimensional image which appears to surround the user. So its application to architecture is you will merge yourself or your client to the design, to your design. You will a new reality will manifest itself to you, and you will be present you will be physically present in a non-physical world. So the problem that was addressed by the innovators is this: the expectation versus reality problem. I just used those pictures because I thought they were funnier than actual buildings. But the problem is, it's like your drawing is like a 12 out of 10, but comes the actual building, it's a 2 out of 10, and that's a problem to owners because they're gonna have to redo the construction because it's a failure. That's it. And the reason for that is because of the lack of communication and understanding between the architects, the construction workers, the contractors, the clients, and everyone that is involved in the design process. So we have these design softwares that we use as architects, but the problem with this is that we use this as architects and we can communicate it best with architects only, and it's limited to that because the clients couldn't fully understand what we're gonna show them. So we have to explain it further. And since our ideas are insane, that's gonna be very hard. So probably some of you might think that immersive architecture is virtual reality architecture, but it's also augmented and mixed reality. So I'll start with virtual reality. Virtual reality is when you immerse yourself into your design, and then everything you see is virtual. So let's say you're walking into your building. So even the skies, the entourage, the floor, everything is virtual. So these are the technologies that we use today that are available in the market. First, we have the mobile VR, which uses mobile phones. And the next is true VR, which uses more powerful technologies like PlayStations and computers. Next. That's an example of augmented reality. Snapchat and Pokemon Go. I just used that picture because I think it's funnier than Pokemon Go. So we get the point. It's basically an object within the reality. Next. So next, this is the tricky part, the mixed reality. So a lot of people might be saying that this is augmented reality, but really it's not. It's an improved version. It's basically an improved version of augmented reality. And the difference between that and augmented reality is, let's say, okay, I'll explain. Let's say you're playing Pokemon Go. In augmented reality, you're playing Pokemon Go, and then you see a Pikachu there, and then you turn in here, the Pikachu is still there. While in mixed reality, you're playing Pokemon Go, the Pikachu is there, and then you turn in here, the Pikachu is gone, because the Pikachu should have been there. So mixed reality has more, the reality is more emphasized in mixed reality than augmented reality. So these are the technologies that are used in mixed reality. So these are the two technologies that are available in the market today. MS HoloLens and Magic Leap. So it's said that in the future, computers and laptops will be replaced with MR. And soon, it's just a theory. Tools for perception. So in order to achieve full immersion with your design, the tools for perception are not limited to sight and hearing, but it also caters to your sense of touch, sense of smell, and sense of taste. Oh, I'm not gonna read that because my point is just it satisfies all your senses. That's it. Next. And how does it enhance urban infrastructures? First of all, it improves the design process of every project. So with an improved design process, you have a sense of reality, and you know how to analyze the problem, and you have a sense of the topography of the site and something like that. And in the end, you will make better decisions. Next is to have a better communication with your colleagues. So, working with teammates can be very painful sometimes. I guess that's why Batman wants to be alone. Next. Next is community engagement. So, in contrast to presenting them your drawings and explaining it to them, it is more engaging to let them experience your design. You give them a hands-on experience. Next is the structural help from VR. So not only does it assist you in computing the structural capacity of your design, it also has a feature that the personnel of the construction industry will have a training of how it's like to be in the site. So they will be prepared for the safety precautions of being in the site. Next. So I just want to summarize what immersive architecture, how immersive architecture helps. So by having a sense of reality, you have a higher state of consciousness, and with a higher state of consciousness, you have a lot more knowledge, and with that comes a greater enthusiasm, and with that comes the ability to make the better decisions. So, according to the Royal Institute of British Architects as of June 2018, so they interviewed 300 architectural firms, and 35% of those uses immersive technologies in their design process, and 79% says that this immersive technology has helped them a lot. That's all.
Thank you, Architect Tiasan. And now for our last speaker, she is a graduate of Mapua University with a degree of Bachelor of Science in Architecture, specializing in urban design. She took her master's in Massachusetts Institute of Technology. She is now the founder and managing director of the well-known architectural firm in the Philippines, Viterbo and Partners Architects. Let us all welcome Architect Patria Celine Viterbo.
Thank you for that wonderful introduction. So before I start, let me give you an idea on what we'll be presenting. We tend to live in a world that our structure is permanent. We wake up each morning saying this outside our house, and the next morning, this, the same structure, over and over again. But what if, here's the catch, what if we wake up saying this outside our window, and the next few days or the next few weeks we say this? Or we see the sun rising in the east, and we see the sunset setting in the west. Ladies and gentlemen, this is the mobile architecture. Mobile architecture denotes two words: movable, which moves easily, and versatile, which is able to adapt or be adopted in different function or activity. So meet Gemma Spessard. Gemma Spessard is a photojournalist, and she loves to travel a lot. Gemma is, with her own savings, she built her own house, and she called it the tiny house. So her tiny house contains, it has its own propane tank for her water heater. She also has a composting tank for her gray water, and she also has a 45 gallons of water for her water consumption. So this is the interior perspective, and for the floor plan, this is the exterior side, the front side of the house and the main entrance. And upon entering, you can see the bump out, the mud area, which she puts her boots and her dog's dishes. And the next this is her bump out area. This is her living room / office / spare bedroom. This is her kitchen. She has a 3-way refrigerator that works on propane, AC or DC. This is her composting toilet, and this is her shower, a 24 by 32-inch standard shower. So this is where she sleeps. Cannot see the lighting's there, but this is her closet / storage / stairs. And in her sleeping quarter, there is a 5-inch Japanese style mattress with netting underneath to prevent the moisture and the molds. So to have a bigger example, meet the family of Sullivan. This is Starla Sullivan. She has 3 kids with a husband, and she converted the bath to be their house, and she called it Great Bird. So this is the typical layout of the bus. It contains passenger seat and of course, driver seat, and 2 entrances and exit. And they removed all the seats inside, and they made it into their home. So this is the SKP plan of their house. And to discuss it further, I divided it into 4 different sections. the first section, second section, third section, and the fourth section. This one is the driver's area where they convert it into a mud area, which is how they put their boots, their outside things. This is their, upon entering the first section of the house, this is their living room slash dining room slash their spare bedroom. And also the seats contains storage. They have storage in there. And there is also their kitchen and their pantry is there. This is the perishable goods and the dry storage. So for the second section is their utility. This is the composting toilet and their shower, their washing machine, and their water heater. Of course, the flooring is waterproof and all the trim are PVC waterproofing. They also hang their clothes to do their laundry inside this shower. And also the third section is their kids' bedroom. Isn't it cute? Their kids' bedroom is it has 2 single beds for their kids, and it also has a wall-mounted crib for their baby. And also the lower part of their below their bed are the storage for kids stuff. So the last section is the master bedroom, and it is also their office, and it has a emergency exit door. So ever heard of the device rotating tower? No? Yes? Okay. The device rotating tower is it was designed by David Fisher from the Dynamic Architecture Group. It is a 80-story skyscraper standing 420 meters above the ground. This is the typical floor plan, and each story rotates in both sides, and it is made up of steel, aluminum, and carbon fibers, which prefab off-site, and it is connected to the central concrete column, this one, and it will rotate. It rotates 6 meters per minute, and it can do a full rotation of 180 minutes. So it is also a green building because it is between the floors there's a wind turbine, and the upper part of each story is a solar panel. And with this energy generating building, it cannot only sustain itself, but it can also give 5 other buildings that is as tall as this one to generate energy. So this is the rotating tower, and it was proposed way back 2008, and it will be built by the year 2020. And if this building will be completed, it will be the 3rd tallest building in Dubai, next to Burj Khalifa and Mariana 1&1. And it will be the first tallest building that is 90% prefabricated. Okay, thank you.
Thank you, architect Peter. Once again, thank you to all the speakers for this afternoon. Now, we would like to call on stage our honored guest, architect Christina Miraflor, for the awarding of certificates. This certificate is awarded to Patria Celine Viterbo. Please come on stage. Ariel Fergas.
Next speaker is architect April Yellow.